Welcome to Chapter 23 on decidability. So we now learned that there are Turing machines that cannot decide every problem. So what are some of those problems besides the language Allen? And what we're going to do is we're going to use the fact that the language Allen is undecidable, and we're going to come up with another problem. For instance, the halting problem in Theorem 69. So the halting problem takes in for input a Turing machine and an input, and it decides whether the Turing machine will halt or accept this input, or if it will loop forever and not accept the input. So it seems like we should be able to decide it. Well, why not just use the universal Turing machine? Well, remember, the universal Turing machine will simulate this Turing machine, and this Turing machine, if it's recursively enumerable, might loop forever if the word is not in the language. So it's not quite as simple, but maybe we could decide to create some Turing machine that can analyze this Turing machine and this input and figure out if this Turing machine is going to go into an infinite loop, or if it's going to halt, or if it's going to crash. So let's say that we've created this. And now this is how we figure out that problems are undecidable, because we create a new problem and we figure out that if we had this solution, that we could create a Turing machine that accepts the language Allen. Well, we know that there cannot be a Turing machine that accepts the language Allen, so therefore we can't create this problem as well. So let's go ahead and look at this halting problem. All right, so we're going to go ahead and create some new kind of Turing machine extensions to this original Turing machine that does the halting problem. So originally it took in a code word and an input word, and if it figured out that this code word accepts the input and halts, it would type yes, and if it got into an infinite loop, it would write no somewhere on the tape. And anyway, we're going to cross off the yes, and we're going to change that to go into an infinite loop. And then we're going to take the no and make sure it goes to a halt state. And we're going to add some more Turing machine steps onto the front. And this Turing machine only takes in a code word, and it spits out that code word copied with a hashtag separating it. And now we feed that in as input to this Turing machine. So now we have a Turing machine, if we look at this as one single Turing machine, that takes in a code word. And if the code word accepts itself, then it goes into an infinite loop. And if the code word would reject its own code word, it halts. So we've now created a Turing machine that accepts the language Allen. And since we know that a Turing machine that accepts the language Allen cannot exist, we know that this machine here cannot exist as well. Now, we know that it's pretty simple to take a Turing machine and make a copy of its input with a hashtag in between, and we can easily do this to any Turing machine. So the only part that cannot exist is the Turing machine that decides if a code word accepts its own input. So that means that it's undecidable. That's right, we cannot tell if a Turing machine will accept its input or not. There's no decision procedure to have that happen. And if we ever did come up with that decision procedure, it would allow us to create a Turing machine that will accept the language Allen, which we know we cannot do, so we cannot solve this halting problem. So look in your lecture notes. There'll also be another video that kind of ties up this halting problem. And it doesn't go too much into detail in this language, or it doesn't talk anything about the language Allen, but it does talk about this halting problem and why it cannot be solved. Now, along with the halting problem, there are three other problems listed in your book that cannot be decided. In other words, there's no decision procedure or step-by-step process that can tell if a Turing machine will accept the no word, or any word at all for that matter, or whether a Turing machine accepts a finite number of words or an infinite number of words. So you can read the proofs of these in the book, but they're going to kind of follow this pattern. They're going to show that if we had a machine that did this, then that machine would allow us either to decide the halting problem or create a Turing machine that would accept the language Allen. And the same for these two languages.